we'll go to the 8th lecture on requirements engineering, covering the topic of requirements management. And with this lecture topic, we are concluding the basic lecture series before focusing finally more on the hands-on sessions, before then concluding the course with guest lectures on future perspectives in requirements engineering. So let's recapitulate for a last time what we did in the past lectures. So far, we have learned how to create our requirements engineering artifacts, and we learned to make sure that they are of sufficient quality for the surrounding disciplines to make proper use of those artifacts, which we learned in context of a systematic quality assurance. Now, there is one last question left open, and which is how can we effectively support the life cycle of requirements also beyond requirements engineering through the systematic requirements management. And this is what is in scope of this lecture unit. So we are following particularly two primary goals. We want to understand what the relevance of requirements management is and what typical tasks are associated with a requirements management, before then concentrating on one facet in requirements management, which is attribution. And we will do this at the example of AMDIRE. Now, same as with the topic on quality assurance in requirements engineering. Also here, we have many more aspects related to requirements management, but these go beyond the scope of the course. And here we will be concentrating again on what we can do from within requirements engineering during the construction of our artifacts to accommodate the surrounding disciplines. Now, that being said, I have created an extended slide set as a small excursion for you, considering also other topics that are very often associated with requirements engineering and requirements management. Among them, the topic of traceability, requirements tracing throughout the whole life cycle, but also how to embed this into a formal change management. And I mean this in the most German way, a formal change management procedure. But keep in mind that this is more for the curious of you to know also how the topics we are discussing in requirements engineering fit a larger picture, typically reflected in a set of further related courses. Now, the two primary goals are also reflected in the outline of this lecture unit, being number one, we want to understand what the relevance is of requirements management and what typical tasks are associated with requirements management, before then dedicating ourselves to requirements attribution at the example of AMDIRE. Now, let's directly start with the first topic. As you may very well remember from the introductory lecture 1, where we introduced the very basic terms and principles of requirements engineering and management, we defined requirements management as a discipline or subdiscipline that aims at efficiently and effectively managing and using requirements along the whole system life cycle, covering also facets that lie beyond what is in scope of requirements engineering, the systematic construction of our requirements engineering artifacts. Elementary tasks include, but are not limited to, archiving and baselining requirements. For example, if we work on multiple releases, how to structure these releases already in requirements engineering, but also modifying requirements due to new knowledge and insights, which relates more to change management and how we can accommodate change management from within requirements engineering, and tracing and verifying requirements, what is typically in scope of acceptance testing, and which is part of the course you are hearing in the next learning period. Now, all this describes, I think, pretty well what requirements management is, but it doesn't necessarily say why we need requirements management. And this is what I would like to discuss with you. What do you think? Why do we need to manage requirements? And maybe take the perspective of what can happen to the requirements during the whole life cycle. Why do we need to manage requirements? What do you think? Any idea? Exactly. Requirements can change, and requirements can change even after going live. So managing properly changing requirements or capturing the reasons of the change and so on and so forth is not only a matter of proper engineering, but also a matter of liability in terms of who has to pay for the change. So requirements may change. What else? Do you remember the story I told you about toll collect? Developing the automated toll collection at the German highway system. This company was facing time boxing. And at a certain point in time, they realized that they couldn't meet the delivery criteria established for the particular release. So they started moving requirements from one release to the other one. So requirements might need to be handled differently with respect to their priorities. So they focused on the most or highest prioritized requirements. In this case, they did it wrong, but or they made some mistakes, I should say. But so requirements might have to be postponed. So this also relates to requirements management. Another thing is that requirements might influence each other, but also might influence other artifacts, for example, architecture-related artifacts. And if you change requirements, you might want to do first an impact analysis. You might want to explore what effects this change of a requirement might have. Another example could be that requirements would have to be reused across different projects. Now, this might not seem obvious, but think in terms of quality requirements and the difficulties of refining, especially high-level quality goals like the system shall be secure to proper requirements. And it might make a lot of sense to try to reusing those requirements that you have elaborately refined in one project in the next. Now, all of these things might not seem overly complicated. And in fact, this is not really complicated if the project is small enough. If we are working on a requirement specification that is maybe 10 or 15 or 20 pages long, this is already complicated, but from a requirements management perspective, this is something we can, I would even say, do on the fly. But this is not typically how requirements engineering looks in reality. In reality, requirement specifications can become really large. And I mean really, really large. So one example I would like to draw from now is a study conducted by Frank Hudek in the automotive sector, where he explored the complexity and the size of the outcomes of requirements engineering. And in that study, he had projects with requirement specifications of up to 2,000 pages. If you would print this out, 2,000 pages. In terms of DOORS, which is a requirements management database-centric software system where you have multiple entries, think of a spreadsheet, we have up to 50,000 objects, 50,000 entries related to requirements engineering, including requirements and also context information. And because this is not already enough, up to 300 externally referenced documents providing some context information, some rules, some constraints, everything that needs to be considered in requirements engineering. And these large requirement specifications, they need to be managed. Because I said automotive sector, 2,000 pages, and I'm not talking about a requirement specification for a whole car. I'm talking about requirement specification for a subsystem in that car. The size of development in terms of, for example, for a car is easily more than 100 million lines of code. 10 years ago, the BMW 7 Series had 120 million lines of software code. And this complexity needs to be reflected in the requirements specifications. And those requirement specifications are used literally everywhere. Remember when I showed you the interfaces and the first requirements engineering lecture. We tend to think about solution in terms of architecture, implementation, but also maintenance and software evolution, but it's used literally everywhere, and also in all the surrounding project organization and management activities. And one of the tasks of requirements management is to facilitate and accommodate the needs of those surrounding activities. And to this end, I can employ different requirements management tasks. Now, here you can see a list of prominent tasks, and the list is very likely not complete. But primarily, first and foremost, when we think about requirements management, we tend to think about attribution. Attribution means that I add attributes to my requirements in the sense of adding meta information for an effective control of the requirements. Here I try to operationalize my requirements in form of context information that make it easier to control the requirements. Another typical task is assessment and prioritization. Assessment in terms of relevance, and prioritization in terms of ranking the relevance and having this relevance reflected also in the meta information of my requirements. Tracing, I mentioned already, describing the life cycle that a requirement might have and how this requirement is reflected in other artifacts. For example, which software component satisfies which requirement and which test case aims at testing which component, and with that also which requirement. This is what we mean by requirements tracing. Versioning, of course, reporting, controlling the requirements engineering process in terms of quality control, but also progress control. So how far are we with the elaboration of my requirement specification? So typical questions I relate to the tasks in requirements management are: which requirements come from which source? How relevant are these requirements? Who is responsible for the requirement, but also who changed the requirements, when and why and how? So these are typical requirements management questions that are related. Now, I don't want to go too much into detail because many of these questions are typically in scope of more management activities, also project management activities. But there's one thing we tend to do from within requirements engineering, and this is attribution. And this is what I would like to discuss now from the most essential perspective at the example of AMDIRE. Now, what is a requirements attribute? A requirements attribute characterizes properties of a requirement for an effective lifecycle management and progress control. As I mentioned earlier, requirements attributes define meta information related to my requirements, and they serve as a basis for a multitude of different activities related to these requirements. So in essence, every single requirement has a set of attributes, and my requirement specification has not only the requirements, but also all the associated attributes related to these single requirements. Now you can see here the list of attributes that we propose in the AMDIRE model, starting with the ID and a description. So ID just refers to the unique identifier of my requirement, and the description refers obviously to what the statement that my requirement makes. Now, if I specify, for example, a functional requirement in terms of a use case, the use case name tends to be, hopefully, the unique identifier of that use case. And the actual use case, the workflow I specify in my use case, the interaction model I specify with my use case, this is de facto the description of my requirement. But other than those more management-oriented, or should say meta information, I have my owner and a stakeholder. So owner reflects who is responsible for the requirement. Stakeholder reflects the stakeholder or the stakeholders who reflect an interest in the requirement. Source and rationale, I have explained already. So the source is the origin of the requirement, and the rationale is the explanation, the justification for the requirement. The state describes the actual state in the life cycle of a requirement. So a requirement can be, for example, validated, then the state is validated. The requirement can be implemented or even already tested, and this is reflected in the state. Acceptance criteria define conditions under which I accept a solution to meet and fulfill the requirement. Time constraints, typically a point in time until which the requirement should be implemented, for example, in terms of a release. And priority, I think, is self-explanatory. Now, instead of telling you why we need all these attributes, let's discuss it together. Maybe not all of them, but let's maybe focus on one example attribute. So what do you think? Why do we need a rationale? The rationale of a requirement I have mentioned, I think, multiple times in the lecture series. What do you think is a rationale for? Why do we want to document a rationale? Remember, a requirement without a rationale is what? A requirement without a rationale, mentioned, is a cost-intensive assumption. So the rationale of a requirement explains the justification of the requirement, and with it provides a good source for the priority of the requirement. How do we capture the rationale typically? So one example of specifying the rationale is just by giving a short pithy statement, just a short explanation for every requirement, why this requirement is there. But it could be also reflected in other content items. So for example, if you have a requirement, a quality requirement that says user data must be encrypted following a specific pattern or technology. So user requirements shall be encrypted. The rationale could be the system goal. The system shall be secure. So here I can start already linking my requirement with other content items. That gives a good justification for the requirement. Now, related to that, the source of a requirement. In this very example, the user data shall be encrypted. The source could be, for example, the protocol from an elicitation workshop where the stakeholders explained the requirement and why they need this requirement. Now, as nearly always in requirements engineering, which ones to take and why to take them very much depends on the situation and the actual project context. So, and this is why we will discuss requirements attribution also as part of the hands-on sessions reflected in the lab sessions and the project Q&A sessions. But there are still a couple of attributes that I would like to at least briefly explain to you, simply because they might not be obvious and self-explanatory. And I would like to start with the state of a requirement. As I've mentioned earlier already, the state reflects the current state of a requirement in its overall life cycle. And what you can see here on the slide is a, I would say, beautiful state model that we have developed as part of a collaboration with a company where we have instantiated the AMDIRE reference model for the custom software development in the field of business information systems, which is also the reason why you might find some related terms in the state model. Now, the state model can be seen as a workflow, and a requirement can be always in one of all these states that is reflected in the state model. And you can essentially divide the state model in two larger phases. One of them being everything that we can do before validating our requirements as part of quality assurance, and everything that happens beyond that as part of more the constructive development-centric activities. So typically, I start by having a new requirement, and this can get one of two different states. It can be either proposed directly by a stakeholder, or you could extract it directly from another source, like a reference description, a reference architecture description, or maybe the requirement specification of a legacy system that you might want to displace with the system. Another state could be that it's an assumption. So imagine that you have an elicitation workshop, you get a couple of requirements, you start the requirements analysis, draw, for example, your usage model, activity diagrams, and then you can spot, okay, this cannot work unless we need something else or other requirements. And here you start drawing these requirements assumptions. Now, during the validation phase, during the constructive quality assurance phase, where you validate the correctness, among other things, the correctness of the requirements with your stakeholders, this requirement, so the proposed ones, but especially the assumptions, might be either killed right away or they might be confirmed. This is what we call accepted. Now, once the requirements are accepted, you move on to the actual development. And here we have two different cases in terms of functional requirements and quality requirements. They directly flow into the development life cycle, but we have also the case of, for example, constraints, implementation constraints, these that are more of declarative nature, these that are more verified by simple review, for example, that we need to use a specific technology, infrastructure, software process model. These are simply what we call applied until the requirement is then released. Now, why do we need this? We need this for an effective lifecycle management. And based on the state model, we can follow things like effective progress control. We can accommodate quality management, quality control, and a multitude of different, more management-oriented activities. Now, the second attribute I would like to introduce is the acceptance criteria. Now, an acceptance criteria, or a set of acceptance criteria, define under which conditions the fulfillment of a requirement is valid. So we define the conditions under which my software system that I deliver fulfills the requirement. And you might also remember that it's quite difficult to refine all requirements, and many requirements might in consequence stay at a more abstract level where the requirement is more vague and very difficult to measure and very difficult to test. So typically we think here of quality requirements, but this is not always the case. For both requirements classes, the acceptance criteria give us the possibility of defining under which conditions, under which circumstances the customer might accept a software solution in response to this requirement. This is what I do to accommodate especially acceptance testing. And this will be also in scope of the course on testing. So what you can see here is one example for a functional requirement, a user story. Remember when I said that user story tends to be measurable, but it's not always the case. If you compare a user story with a use case, where you specify, for example, detailed activity diagrams, you could see that both describe a functional requirement from the perspective of an end user, but both are at different levels of details. A user story is something more abstract. It's something more easily specified, something quite tangible, but there's a multitude of ways of interpreting this user story. And the acceptance criteria give hard criteria, hard conditions that need to be fulfilled. Here at the example, thinking back also on the lecture unit on quality assurance. In terms of quality requirements, think, for example, of those requirements that tend to be rather difficult to bring down to the level of measurable or testable requirements, for example, usability requirements. The acceptance criteria for usability requirements can be often expressed in terms of norms or standards. For example, that a company defines a specific accessibility standard or a specific standard that defines how graphical user interfaces should be constructed. And this is what I can take as an orientation to define my acceptance criteria. Now, last but not least, of the quality attributes I would like to introduce is the priority. Now, a requirement's priority documents the importance of a requirement in comparison to other requirements according to given criteria. Why would we want to prioritize the requirements? Because at some point we will always need to decide which requirements to prioritize higher than others. For example, in terms of decision making, when I might need to postpone requirements to other releases, sometimes if I run out of time, sometimes if I run out of budget, I might have also to decline requirements or to kill them right away. So this is which brings us to the relevance of a prioritization techniques. Now, one of the difficulties in capturing the priority of a requirement is to choosing which technique I should use. So three prominent techniques that you will find very likely in literature are the ones you can see at the bottom of this slide. We have one option that is very often subject to debate, at least, that is that I can rank or have my stakeholders rank the requirements according to their relevance from their perspective. This is ranking by stakeholders. The other option is that I prioritize my requirements in terms of cost and benefit. We have discussed this in a context of non-functional requirements. And the last option is the so-called $100 method or 100-point method. Here, what I do is for every single release and my set of requirements associated with the release, I give my customers, so all the stakeholders, 100 points or 100 fictional dollars, or euros, if you want to give them some value, to distribute over the set of all requirements. Now, whatever technique you use, there's always some benefits and always some drawbacks and difficulties. So let's discuss these advantages and disadvantages for the mentioned techniques just to get a feeling for those techniques. Now, ranking by stakeholders, what do you think? What is the advantage of not me doing the prioritization, but having my customer prioritize my requirement? What do you think? What is the advantage of this? Anyone? I know what you mean. I think I know what you mean. And I completely agree with this. So you don't have the insights, the same insights that the stakeholders have, and the prioritization might not be reproducible, at least from the perspective, for example, of an architect. Now, here's my thought on this. If you ask stakeholders to rank the requirements from their perspective, it's easy. I shift my responsibility as a requirements engineer to the stakeholders. And the way of thinking is clear, because I think that if not them, who should know best how relevant the requirements are? But here's the problem. It is in the nature of human beings to always see their own requirements as the most important ones. And very likely you will end up with 99% of all requirements having the highest priority, simply because you have a multitude of different stakeholders. And this is something very, very difficult then to consider. If I was a stakeholder, chances would be rather low that I would say this requirement is a low priority. This is what I mean by the nature of human beings. Now let's consider prioritization based on cost and benefits. What is the advantage and the disadvantage? I mean, cost and benefits, I would say, is something very, very accurate. But as you may remember from the lecture on non-functional requirements, when we talked about cost and benefits, relevance and cost, it's not easy. I would say it's even up to impossible. And now imagine having to do a calculation of cost and benefits for thousands of requirements. This is just not feasible. The $100 method. Imagine you are in a release and then you are the customer and get 100 points to distribute to the requirements. I would say this is a fair approach, but it might also not be a realistic. Consider that you have a release where you have two requirements that come from legal constraints. For example, GDPR compliance. There's no way around these requirements. And in consequence, you might have to distribute the points you have to those requirements, but maybe have to prioritize rather low those requirements that actually matter from a functional perspective most to the stakeholders. Now, all this, and another thing, it's quite complicated. We have tested this in agile context. It works, but it's quite complicated. So these techniques have all benefits, but they have also all drawbacks. And this brings me to the I don't want to say last recommendation, but it's in this context, last recommendation I would like to share with you. And it's a prioritization technique that is very, as I believe, underrated. And it's the MuSCOW approach. Now, the MuSCOW approach is one approach that you will find very often in practice. And it's very pragmatic, and yet it's quite effective. Now, we distinguish in the MuSCOW approach 4 different priorities that I can give. Must have, should have, could have, would have. And this is also the abbreviation for the MuSCOW approach. Now, must have includes all those requirements that are imperative for this particular release already. So typical requirements that are associated with must have are the legal ones, the based on regulatory environments, constraints, things that must be present from the very first release. The example I mentioned now, GDPR compliance, is one such case. Should have are must-haves in the long run. So they are maybe not vital for this very release, but they must be present at the final outcome of my software system, because these are the requirements that add the actual value to the software system. Without these requirements, the system is without value to the stakeholders. So should have means it is a must-have, but maybe not now. At some point, however, they need to be treated as a must-have. Could have are those requirements that are often associated as nice to have in the long run, but they tend to have maybe a smaller impact if left out in the in terms of correctness. Typical requirements classes that are associated with could have are non-functional requirements. While, for example, the should have requirements are those that help us, identifying the unique selling points of a specific application in terms of functionality. The could have requirements are very often, at least, those requirements that make a difference between otherwise similar products in terms of quality. Now, would have refers to those requirements that would be great to have them if we have enough money and time. So this is just a very pragmatic way of using, a prioritization technique that is still effective. And one of the major strengths of this prioritization technique is that it shifts the responsibility to the requirements engineers, which means that it is up to us to put some thoughts and to really understand the backgrounds of those requirements. And if I don't understand the background, it forces me to come back to the stakeholders and discuss those requirements in more detail. And this is the one I would recommend you to at least try out in your project and your assignment, which brings me to the conclusion of this short lecture where we discussed the requirements management principles, putting directly focus on the attributes which we can use. And as you have seen, we have a multitude of different options for attributions in our requirement specifications. What I would like you to do is to put some thoughts into which attributes might play which relevance to your projects and how you could plan to manage them pragmatically and yet effectively. So put some thoughts into this, brainstorm, and let's discuss them as part of the hands-on session. So the last reminder again is that I have created a small extended slide set for you covering 2 further topics as a form as an excursion, one of them being requirements traceability and the other one being a formal change management, to show you how the things we have learned in requirements management, if getting a larger picture, fits into the surrounding software development and software management or project management topics. With this, I would like to end today's lecture unit. Thank you very much, and it's time for questions.